This is an example demonstrating the universal instantiation rule. We call it fathers and sons. The story is this. Our universe is the set of male people. We assume that if anyone is the father of a person, then that father cannot be the son of his own son. Thus, no one is his own father. Let's begin by defining the predicate. F of x and y means x is the father of y. From the story and the predicate, we may represent the premise as, for all x, for all y, f of x and y implies not f of y and x. In English, that is, if anyone is the father of a person, then that father cannot be the son of his own son. The conclusion we seek is for all x, not f of x and x. That is, no one is his own father. Once again, symbolically, the premise is, for all x, for all y, f of x and y imply not f of y and x. The conclusion is, for all x, not f of x and x. So how would we construct a proof of this? Let's begin by looking at the conclusion, which says that for all x, f of x and x is false. How do we get that from the premise? The premise involves an implication, and in that form, it's hard to see the conclusion coming from the implication. Let's consider what would happen if we were to replace the implication by its conditional disjunction form. Inside the quantifications, instead of f of x and y implies not f of y and x, we would have not f of x and y or not f of y and x. So either f of x and y is false or f of y and x is false. This must be the case for every x and y, in particular when x and y are the same. If they are the same, f must be false. So our key to proving this is to instantiate x and y to the same symbol. If you would like to complete this proof on your own, please pause this video now. We begin the proof by listing the premise on line 1. For all x, for all y, f of x and y imply not f of y and x. We do a universal instantiation of x to the arbitrary symbol a, resulting on line 2 with, for all y, f of a and y implies not f of y and a. On line 3, we universally instantiate y to the same arbitrary a to result in f of a and a implies not f of a and a. If we apply a conditional disjunction to line 3, the implication is replaced by the disjunction not f of a and a or not f of a and a. Idempotence to line 4 results in line 5, which is simply not f of a and a. Since a was arbitrary, we may apply universal generalization to line 5 to get line 6. For all x, not f of x and x. That concludes the proof.